We're starting with conic sections here. So conic sections deals with three things: ellipse, parabola and hyperbola. What conic sections are is slices taken off a cone. So if you cut a cone horizontally straight across, you'll reveal a circle. If you get a cone and you cut it at an angle and basically slice through one side and come out the far side, you get an ellipse. If you slice the cone parallel to the side, so here's the side of the cone for example, you slice down through the cone, cut down through it parallel, you will get a parabola, and this is our parabola shape. And then we have the last shape, which is what we call a hyperbola. It's similar looking to a parabola, but it's found slightly differently. So the parabola is done only, and you only get a parabola if you slice down through the cone parallel to the side. A hyperbola is found if you slice down through it at any other angle, so vertical or any angle that isn't the parabola angle. And the hyperbola is most commonly found cut vertically, so most of the time when you see it, it'll be a vertical cut. Where the parabolas come from, if you have an elevation and plan view, so we've got our elevation and plan, again we said the parabola is sliced parallel to the edge of the cone. Here's the edge of the cone in elevation, slice through the parabola, and this is the reveal. So that's the true shape of the parabola revealed. We have a plan view that shows the parabola, but it's not a true shape. We have our ellipse. Again, same thing with the ellipse. Ellipse, you cut in one side and out the other side, so it doesn't cut through the bottom of it. It comes in one side, out the other side. Our true shape that's revealed is our elliptical shape. And then our hyperbola, as I said, the most common version of the hyperbola is a vertical section, so cutting down straight through the bottom of the hyperbola, and it reveals the shape here, which is the true shape. Now, the three views that I've shown you there are sections of cone. We're going to draw these conic sections with the eccentricity method, and the eccentricity method is mathematical. It's basically using maths and ratios and measurements to draw the three shapes. The ideal thing though is that you use the same process to draw an ellipse, a parabola and hyperbola when you're doing the eccentricity method. So it's the same method for drawing them all. We start with the parabola. So the eccentricity method for a parabola, there's as I said, a method we use for the three different types of curves. It's all the same. To draw a parabola using an eccentricity method, you need to start off with a directrix, which is just a vertical line, and an axis, which is a horizontal line. You have a focus of the parabola. I'm going to step out 40 mil just to put in a focus, and I'll call that F. The whole question here is to find what we call an eccentricity line, and it's a line that let us draw the curve. We have a formula for all of them. Again, this is for the parabola, but you can use it for ellipse, hyperbola, it doesn't matter. Eccentricity equals F to P divided by P to D. What that means is from the focus to any point on the curve divided by the distance from any point on the curve to the directrix, and I'll explain what that means a bit more. But for a parabola, it's always 1 is to 1. What that means is that the distance from the focus to any point on the curve is always the same as the distance from any point on the curve to the directrix. We can measure in 40, and what that means is I can measure up 40 because it's a point on the curve, and I'll just show you it and then we'll explain it. So in 40, up 40. What it means is when you draw a parabola, you get an eccentricity line of 45 degrees. So your eccentricity line is drawn from the directrix and axis where they join up here at a 45 degree angle. To find the vertex, so the vertex is the top of the curve or the end of the middle point of the curve, we just come at 45 degrees to hit the eccentricity line, and we come down vertically. That is our vertex. We have what's called the focal line. that comes straight through the focus. So a vertical line that comes through the focus. And as I said, we call that the focal line. And now we've got everything we need to start actually drawing the curve. Okay, the method for drawing the curve. From your focus, you can step out in equal measurements. Doesn't matter what size they are, I'm going to step out in tens. 10, 20, 30, 40, 50. So we'll step out a few measurements. And I just call that 1, 2, 3, 4 is probably actually enough. We draw vertical lines above and below to hit the focal line from each of those. And we continue back horizontally to hit the focal line. Now I'm just going to extend the focal line a little bit here because it needs to be a little bit higher. So where our line 1 hits the eccentricity line, I come back and do that for each of those. So as I said, we stepped out equal spaces, draw vertically to hit the eccentricity line, and then come back to hit our focal line. To find the points on the curve, take our distance from the focus up to our focal line, and we just swing that around onto the line, above and below. So there's number 1. So 1 comes swung around here and down below. I swing 2, and 2 will be a bit more obvious. So I swing 2 out to hit the line and below, so down below number 2. Number 3, swing it out and below the line. And then we have number 4, and again swing it out and do the same below. That gives me a section of points on the line. The cross here between the eccentricity line and the focal line is a point on the curve, so I take that above and below as well. And we have a series of points on the curve. Now we can do the same going in the way. So in other words, I stepped out here equal spaces, I can just step in the way a 10mm space as well, so I'll get another point in here. And again I do the same thing, up to hit the eccentricity line, and again I'll draw it above and below, and come back to hit my focal line. Same thing again, from the focus, measure up to the line, and just swing it to hit the line above and below. So we're swinging the curve. We find a point and a point. That gives me all the points in the curve, and now I can draw on the parabola. So I'll quickly sketch it in and you'll see what it looks like. Okay, so that's the curve drawn in, and it goes through the vertex and back out the far side. This F to P and P to D, what this all means, from the focus to any point in the curve is the same from that point to the directrix. In visual terms, or if I draw that out, what that means is if I take a distance from the focus up to any point in the curve, we'll say for example up to here. So I just draw on any line up here. So that's from the focus to a point on the curve. That distance is equal to the distance to the directrix. So when we're drawing a parabola, the distance from the focus to any point, we'll call it P, is equal to the distance from that point horizontally to the directrix, which we'll call it D. So that's where our F to P is 1 unit, P to D is 1 unit. So it's the same. And that is replicated all over the parabola. If you look at the distance from the focus straight up to here, that distance is the same as this distance. So those two distances are the same. Likewise, the distance from the focus to the vertex is the same as the vertex to the directrix. So in other words, that's focus to a point on the curve to the directrix are the same as well. And you can kind of check those with the compass. So there's my distance, and it's the same distance. Distance and the same distance. And that's what our F to P over P to D means.